Formula 1 is a sport in constant evolution. New technologies, new circuits and new regulations are always on the horizon. And in 2026 a major step forward is coming. Not just a small little tweak, we're talking here about a totally new car generation. The upcoming 2026 Formula 1 car will be radically different from what we currently see on the grid. First, car will run on 100% sustainable fuel. Teams will have new financial regulations and, what we'll be diving into today, a completely new bodywork philosophy. In today's video we'll analyze the aerodynamic changes of 2026 F1 car, highlighting both its strengths and weaknesses, and explore what it all means for racing. If you learned something new from this video, be sure to leave a like and subscribe, it really helps to the channel. Let's begin with the main bodywork changes. The wheelbase is shrinking by 200mm. Overall width is being reduced from 2000 to 1900. Minimum weight drops by 30 kilos, but that is just the beginning. The front wing becomes narrow and less complex. The rear wing is simplified, with a smaller angle and surface area. 18-inch wheels remain, but the tire width is reduced. The beam wing and wheel deflectors are completely gone. Floor tuners are significantly simplified. These changes go far beyond just design. They reshape how air flows over, under and around the car entirely. Look closely at the front wing, it feels almost retro, resembling wings from the early 2000s, but this is more than just a throwback. The wing has a spoon-like shape, dipping in the middle. This creates a mini Venturi effect, where air accelerates through the narrowed gap between the wing and the track, reducing pressure and increasing downforce locally. A simple but clear aerodynamic solution. Moving further back, the suspension design tells another story. Like in the 2022 cars, the suspension components generate lift, not ideal for a car that aims on downforce. But even more interesting are the airflow elements mounted just ahead of the suspension arms. These also produce lift. Why? Because the new front wing sends a strong upward stream of air into them. Changing the angle of these small foils might help mitigate that unwanted lift and bring back some stability. The wheels are another aerodynamic challenge. Open wheel design makes controlling turbulence from tires extremely difficult. Each wheel produces a strong wake that must be managed. The 2026 car addresses this with a high bargeboard-like structure near the leading edge of the floor. Its job is to disrupt and control the wake, and this visual suggests us that it actually works. It prevents wake from forward spreading. Compared to the previous generations, large leading edges, the 2026 car have them totally redesigned. This still generates useful vortices that energize the airflow under the floor and support downforce, but in a more refined way. Looking at the floor and diffuser, things start to get interesting. On the surface friction visual, the new floor appears similar to previous generations, but switch to pressure visual and the differences are visible. Previous generation cars generated more downforce through the entire floor, especially in the middle. This is largely due to the floor tunnels, which are now reduced. Previously, whole floor had different width and height. Now, the only value which changes along the floor is width. Without them, the 2026 floor can't squeeze airflow as effectively as previous generation. At the rear, the diffuser still helps, it expands the air outward, lowering pressure and supporting rear end grip. Other elements like the T-cam and halo also produce lift, exactly the same as 2022 car, but interestingly the new halo design generated slightly less lift than before thanks to a less steep angle. Now let's talk about the rear wing and the loss of the beam wing. The new rear wing design aims much less air than before. Its angle of attack is reduced, its surface area is smaller and the beam wing is eliminated. All of these changes are about smaller downforce and reduced drag due to this. And that's one of the 2026 car's core aerodynamic goal, minimize drag as much as it possible. We all know how powerful is open rear wing on the straights, also known as DRS. but front wing also faces huge amount of air, so if we open it, the drag should reduce even more. The same way thought FIA engineers. Instead of just opening the rear wing in the air zones, 2026 cars will have both front and rear active aero with two modes, Z mode and X mode. Z mode is the high downforce setup for cornering. X mode is the low drag setup used on straights. This gives driver more flexibility to optimize grip and speed, something truly unseen in F1. And based on my CFD simulations, the 2026 design achieves a drag coefficient of 0.65 and a lift coefficient of -1.1. That's a 25% drag reduction and a 55% drop in downforce compared to the current generation. A fundamental shift. These cars will be less stable in corners, but faster in a straight line, creating more opportunities for overtaking. If you're interested in running your own CFD simulation or want to test your own aerodynamic design, visit osaerolab.com. You can submit custom simulation requests. Moreover, on the site you will also find a technical article dedicated to the 2026 F1 aerodynamic changes, exploring even more of the clever features hidden in this new design. The link is in the description. Huge thanks to Qvist Designs for sharing the incredibly detailed 2026 F1 model used in this video. Make sure to check out his social channels, his works are seriously impressive. So let's wrap things up. The 2026 Formula 1 car is all about balance. Less drag, less downforce, more overtaking. It won't be as stable through the corners, but it will be faster on the straights. The regulations highly aim for driver competition and strategy, not just roll-up time. Thanks for watching and let me know your thoughts in the comments. Do you think these changes will make F1 better? Or are we losing the essence of high downforce racing? See you in the next Aero analysis.